Hello everyone. For this tutorial, I would like to share about the computing aspect of the RPi4B and the Max-E2 project. Previously, if you remember, I already made one regarding the mechanical integration aspect. So this time, we'll talk about the computing aspect. So what are the topics? I'm going to share with you the final power option I chose for the Max-E2 and RPi4B project. We'll go over the dynamic social network design and finally zoom on and apply. I will share some software design feature that was kind of interesting and a little bit new, and then a quick demo video at the end. So you can see it, I need to have separate power cable for the CM550 and the RPi4B. And if you've seen the other project where I did it for the spy robot, the battery just not gonna last long with this one. And to have a very big battery, and then we're gonna have to create out of balance problem with this humanoid robot. And because this robot it has even more servo working together than the spy robot. So you can see I have a connection here for the RPi4B, and then another connection here for the CM550, and then so you can see that two long cable attached to it coming out from the end. And the next important point, of course, you probably figured it out too, is the motion offset determination. Because once I put the RPi4B in the back and all these cables and stuff like that, it makes the robot lean backward. Keep it out of balance, almost out of balance. It could stay in erect okay, but walking backward, forward, left, and right kind of doesn't work too well. Let's put it that way. Also, in the previous video tutorial, my thinking was, because this robot, if you have played with it before, is when it's walking forward, backward, and left, it starts from the basic pose. So we say it crunch down a little bit and then walk from there. So previous I thought, okay, if it start walking from forward backward from there, I need to zoom on the basic pose and then try to keep the robot gain a new balance set or balance point with the RPi4B behind it, in its back. But it turned out that's not the case. I found out that if you put it into a ready pose, and the ready pose is the one that put it straight up, alright. And when you do that, you're gonna find out that the legs here, I thought maybe I had to adjust the angle of the knees. It turned out that's not the spot. They stay erect, but you can see that the robot bend backward around the axis of servo 6 and 8. So that was interesting. That was at least something new I learned when I do this project. So it turned out to be 6 and 8. If you add a motion offset about minus 4.5 degrees to it, will straighten up the robot. And you see in this case here, it actually maybe leaning a little tiny bit forward too in this case. But this motion was good. And then I was surprised, but then when I applied it to forward, backward, left, and right, it started doing pretty well without having to adjust any of those motion pages at all. When you set the motion offset for the ready pose, it works for the going forward, going backward, turn left, right. Most of the time, put it that way. And it will go forward, left and right very well all the time. But I noticed that sometimes when it goes backward, not all the time, but sometimes this robot will fall on its face. Meaning that somehow the CG start getting too much forward beyond his toes here, so it would fall. And the funny thing is, I tried different number, minus 4, minus 4.3, go to 5 maybe, and so on. And I couldn't one that work for forward and backward at the same time. One of them will kind of fail, but the other one will be good. So I say, well, it looks like I may have to think concept-wise, and not sure this is correct or not. Some roboticists out there are probably going to correct me. But I consider the motion offset setting here, and I would say I actually call it, or I think of it at least, as a static component of robot balance. So remember I put minus 4.5 to 6 and 8, and I call that the static component. the robot balance. Okay, but at runtime, I want to add a dynamic component to it, a +2 degree. And how do I do that? I use the so-called adjusted offset or joint offset, depending on where you read it from the menu in the task code, or you see it from the e-manual information for the XL 430. So during backward motion only, I set up the code so that it gave a joint offset of +2 degree to 6 and 8. So remember, they have -4.5 degrees that we say all the time, but when the robot going backward during that time, +2 degree to it. So that means it's only -2.5 degree when it goes backward total for the servo 6 and 8. So that was kind of interesting thing I had to figure out and kind of adapt. That will be interesting to see if it applies for you guys' robot if you have a similar project. Number 2, independent dynamic network design chosen. Same thing as a communication scheme open. So the RPi4B will be controlling the neck and head servo, shall we say, where the camera attached to, or the camera is attached to. So servo 19 and 20. It will control that through dynamic XDK using U2D2. So TTYSUB0 for the Pi camera at 1 megabit per second. The camera itself, the best I can do is 640 by 360 and 90 frames per second using just plain open CV framework. I had some problem. I couldn't use GStreamer on the Pi camera yet for my 64-bit OS, which happened to be on beta, so that part of it is still broken. Couldn't do GStreamer framework here. Alright, so once the RPi4B study the images and all of that and decide what to do with the CM550, it will send remote control packet radio USB cable at 115.2 kilobit per second. And then the CM50 just use, motion offset, joint offset, motion unit, motion pages, and so on to take care of the arm and length servo to move the robot around. Another surprise I found. Okay, so these are the motion units that were created by Robotics already as an example for ME2. And I found out that, I use 100. That's that's the ready position, is like the basic position. Crunch it out a little bit, and then I add the these motion unit. Like for example, 101, it just start going forward. 105 is stop going forward. So that means basically when you attach these two motion units together, you make the robot make one step forward, and then these two to make the robot go one step backward. And then here is spin left and spin 2. And you notice, and if you already used motion unit before, this below here, this triangle here, point to a place where you can put in the exit motion. If you notice, all these things are all black. What happened to the exit motion? You couldn't set it up. So I emailed the robotics technical folks over in Korea and asked, what happened, guys? And what I found out was these, because the Max E2 is very sophisticated motion units, so they use up too many keyframes to make all these motion for it to walk forward, backward, spin left, spin right already. There was no room left in their data structure that I can add an exit motion. And remember, in the previous project, I have exit motion because I want to add some kind of obstacle detection autonomous function for it, so that when it sees something, it needs to go to exit motion to stop the robot, shall we say, graciously and safely. So there's no exit motion I can use anymore. So no obstacle avoidance and a feature for the Max E2 in this project. So it's just gonna go one step at a time and stop and do another step essentially. Okay, so nothing real exciting as far as motion unit, shall we say, interaction or any fancy feature with motion unit this time. I added a new feature for the head assembly. I call it camera only mode, basically where the two servo 19 and 20 I can set it up so it just track the whatever color object I set up on it using the camera only, essentially using it head only, the two servo 19 and 20. And then I can turn that feature off, see off, on and off, and then the robot also trying to move the camera and also move the whole robot, the legs, and moving forward, backward, and left is trying to track the color object that I want it to track. So let's see how it looks like. So this is a capture of the screen on the RPi4B. If some of you noticed already, it started off showing low voltage already, and this has its own cable. So so this code seems to be very intense, just using the U2D2 and all the camera at 90 frames. It seemed to be draining quite a bit. Okay, here's a little larger webcam to look at the outside. Before this video start, I already tell to extract out the data for a red ball, and I tell to track already, but I set up so that it will track using the camera or the head assembly only. After I done that, and I reset it, and I essentially added the feature where it will have to move the whole robot, trying to track the red ball also. And then remember is the code is written such that once you remove the target out of field of view, that means the open target frame here showed nothing. It couldn't find any target. It will stop the robot where it was. Okay, and you can see I do that several times in the video, so you can see that if you take it, it just stops. It won't do anything. And then at the end, after it's walking and trying to track the ball, and then I just remove the trackball, and at the end I push the reset button, and you can see that the head and everything go to the basic reset position for this robot. Okay, so let's do it. Okay, I got everything tracked. You're about to see I stick a red ball in there, and then you see it tracking it, just the camera only. The camera only is set up so that if it found some object in the 1/3 or half of the screen, that's when it's tracking the best. If it's far too out here, that's when it tells the robot to actually move. It won't use the camera to track that. So now you see a little bit better now. You see it trying to follow. But with the head only. Okay, so now I stop, I take it away, I just put it into the mode where it will have to move the body. So here we go. Okay, so I just removed the red ball. You see it immediately stopped, froze, and now I pick it up again. Oh, on my robot, I don't know if you build your robot, my robot turned right very well, but it couldn't turn left very well, so I have some issues there. But I'm just trying to do his job. It looks like it's about to fall pretty often, isn't it? So now I'm going to push it to the reset button. Here we go. I select the reset button. It just go that way. So finally, all those projects, I finally put them into the volume 1 of project guide now. So I'm wrapping it up now. This book should be ready in October 2021. And hopefully, thank you for your support in advance. Until later.